Okay, I'm looking forward to this. Kinsey Bridge metal grid deck replacement. This is Brent Schiller and Jared Larkin from Forsgren. Please welcome these two.
Well, afternoon, everyone. Thank you for attending this session. And this is about the Kinsey Bridge metal grid deck replacement. As he said, my name's Brent Schiller. I'm with Forsgren Associates. I was the project manager on the bridge design. This is Jared Larkin. He'll be doing the second half of the presentation. He was our lead bridge designer on this project. So I wanted to mention that this was kind of a fun project for us just because it was something a little different than our standard concrete deck on girder type bridge. As the name implies, we used an open metal grid deck. It just kind of fit the situation for what the owner and client wanted. And so just something we don't typically do out west, or at least that we've done out west. And MDT's project manager, Scott Walters, actually said that this is the first time they think that it's been used in Montana to their knowledge. So something a little different. So we'll talk about where this project's located. It's in Custer County in southeast Montana, 9 miles northeast of Miles City. It goes over the Yellowstone River and just kind of off the interstate. So, and go through the project team roles. So Custer County was the owner. MDT provided the bulk of the funding, and also they performed the roadway approach design. And then, of course, Forsgren did the bridge design and plans. And then Wadsworth Brothers was the won the contract to do the construction for us. So some bridge fun facts. This was built in 1907, 116 years old. So it's getting up there. Originally a single-track railroad bridge for the Chicago, Milwaukee, and St. Paul and Pacific Railroad. So quite a mouthful there. It's got 4 Parker through trusses, each 270 feet, so 1,080 feet out to out in length, skew of 10 degrees. And then it was abandoned by the railroad in 1980 and subsequently converted into a county road bridge. And that photo there we happened to find on the internet from the Library of Congress, taken not too long after it was abandoned. So kind of a nice photo there. So reasons for the project. The deterioration of the deck was causing safety and compromising the commercial effectiveness of the route. It was used a lot for local residential access, agricultural use, and business use. You can see the FedEx truck traveling across there that our inspectors took. And then the continual deterioration, to actually repair it and keep up with it was just kind of beyond the ability of Custer County to replace, both technically and fiscally. So MDT came in with the funds and helped them out there. So for the rehabilitation process, we went through a pretty standard process. We did a field investigation, sent teams out there to look it over and document. And then while that was going on, we kind of discussed the needs and wants with the client or clients with MDT and the county. And then we took that information, we put it into a recommendations report and came out with the preferred alternative of the metal grid deck. Took that into design, prepared plans, bid it, and took it to construction. And then we're going to talk about each of those here. So let's talk about the field investigations. That picture on the right side kind of tells the story. So a lot of deterioration going on. There's some metal planking there, and if you look closely on the top part, there's a lot of steel plate patches. And that's actually a repurposed planking from a World War II era airfield. One of the county people told Jared that when he was out there in the field. And then you can see there's a hole there in the timber planking, some makeshift cable railing on one side, makeshift W-beam on the other. That's supports for that are actually welded onto the truss members itself. So a lot of stuff going on, and there's some erosion going on near the roadway abutments, or the abutments for the bridge and the roadway, and they on the roadway side they put in some block retaining walls. And then our field crews took a lot of photos, documented measurements, kind of verified the plans that we had, so we had the information for the recommendations report and also for design. Talking to the client, needs and wants. Every county will tell you they want you to minimize their maintenance needs, right? And on this one in particular, it was winter weather considerations. This was a single track railroad converted to a single lane roadway bridge, and very little room. As a matter of fact, so little room that the county can hardly get their snow plow through there. They have to really crank the plow and try and work around it, and we think it actually impacted some of the knee braces a few times. So that was a big deal for them, and they can't just de-ice, use de-icing salts because those will run off and not interact well with the steel truss. So that was a big deal to them. And then when we were talking about options, particularly the steel deck options, one thing we kind of went back and forth with them on is, should we use galvanized deck panels or should we do weathering steel? Weathering steel was consideration because it kind of matched the look, but galvanizing won the day because of public perception in the county's eyes. They were worried that have this multi-million-dollar replacement go on and have the public see a rusting steel deck would not bode well. So they wanted galvanizing, which we did. So talk a little bit about the recommendations report. Obviously, we replaced the deck with the open metal grid deck. No surprise there from the title of the presentation. We did consider 5 other options. I'm going to kind of go through those in the next slide in more detail. As part of preparing the recommendations report, we did do a load rating analysis of the entire truss. We wanted to make sure whatever option we went with would not compromise capacity. And the results there on the right side, you can see 1.4 at inventory level for HL93, well above what we needed. And that was actually controlled by the new floor beams. So the actual truss itself, built for railroad loads, as you would expect, it's going to sit there and smile at you all day long with trucks going over it. So we also recommended, obviously, new railing because what was there was very insufficient, and then the repair of the approach roadway. I want to mention our focus from MDT and our scope was really to focus on the bridge deck and then some obvious things such as the railing, but not go into full mode rehabilitation of every little nick and ding. So here's the deck options table that we had in the recommendations report. We used kind of a stoplight thing, of red's con, yellow neutral, green's a pro, trying to make it easy for the county to review. We had the 6 options across the top there. Option 1, corrugated steel bridge planking with just a gravel fill, so the planking was the structural element. Option 2, corrugated steel bridge planking, but as a form for a new reinforced concrete deck. Option 3, the open grid metal decking, which we actually selected. Option 4, timber deck with timber ties, so essentially a replacement in kind for what was there. Option 5, a concrete filled metal grid deck, and then option 6, a precast concrete panel system. Well, we got together in a meeting with MDT and the county, and as we started looking at this, options 5 and 6, the costs just were much higher than the others. We eliminated those right away. And then option 1 and 4, which were the 2 least costs, we eliminated fairly quickly as well because they both were seen as having ongoing deck maintenance needs and probably a relatively shorter lifespan. And then also needing probably a deck drainage system. There was a concern from MDT Environmental that if we placed it with some kind of solid deck surface, that any de-icing salts, because they can't plow it, would running off into the river was something they didn't want. So they wanted us to collect it in the drainage system. So that was seen also as a maintenance thing, so that got eliminated. And then option 2, which was a better option, but also had the drawback of a drainage system, that got eliminated. So option number 3, which was the number 4 cost option, was actually the one everyone agreed we should move forward with. And a little unusual, don't go with the least cost option, but that definitely fit what the county needed, and MDT was very agreeable to that. So with that, I'm going to let Jared talk to you about the bridge design, since he did a lot of the nuts and bolts calculations. So.
Hello, everyone. As introduced, I'm Jared Larkin. I did a lot of design work for this bridge. Let's get right into it. So on the screen here, I have the bridge design typical sections, the old typical section right next to the new typical section. Let's get right into that. For the old typical section, as you can see, there's not a lot of clearance for vehicles of any sort to get down the bridge deck. There used to be timber curbs on the deck, although they're missing lots of locations. There's just 9.5 feet between those. If you took it out to out as far as you could go without hitting anything, you'd be just left with 11 foot and 1.5 inches. So there really wasn't a lot of space to work your way down this deck. And if you got over too far, you get off the timber ties and just onto the timber planking, which isn't really designed to hold heavy loads. So that was also not seen as being very safe. The new typical section tried to address a lot of the issues and concerns. You can see on there, we put the metal grid deck and we put those on top of new floor beams. And the floor beams also served a purpose of raising the deck up higher, which increased our clearances that we had for vehicles traveling down the road. It gave us a 12-foot clearance between the knee braces. And then we attached the railing to the end of the floor beams. And while the face of the railing didn't go past the knee braces, we figured the shy distance from the railing would help protect the knee braces far better than the existing system was. So let's just start going through the process. We start with the deck design. The existing longitudinal stringers are spaced at 7.5 feet. And at first we looked at putting the deck panels just straight across the existing stringers, but we determined that wouldn't work. With just those spans, we just couldn't get the capacity we needed with the metal grid deck. So we determined adding new transverse floor beams to reduce deck spans, remove the deck overhangs that would have occurred if you just spanned across the existing stringers. Determined that was the best way to go forward with that, and that had the side effect of raising the deck up higher, which ended up being a pro in this situation. There was a lot of design work involved with the deck to floor beam connection, just determining how to best attach the deck to the new floor beams. We consulted a lot with the Bridge Grid Flooring Manufacturers Association, or BGFMA, for this process. Mike Riley, the executive director, is our contact there. He's really helpful through this process. Anyone interested in metal grid deck, you can call him. He knows a lot more than I do. We threw his contact information up there just for anyone who might be interested. We also spoke with fabricators and local bridge contractors to kind of determine the optimal connection that'd be easy for them to install. And I'll talk more about the connection we picked a little later during the construction phase, as I have some better pictures there. So I do have a picture here that kind of shows the end system, just showing the longitudinal stringers there and how the floor beams ended up landing on top of those with the deck panels on top. So speaking of I mentioned earlier that the railing and posts, those were attached to the floor beams. We determined that was the most economical way to move forward with this, as you could potentially attach the post to the top of the deck, but then we needed to make the deck wider and then extend the floor beams longer. It's just we reduced our material costs by attaching the post to the end of the floor beams. Those did affect our floor beam spacing, as our post had a maximum spacing of 8'4" for the rail system we selected. And we needed to adjust the spacing of the post to make sure we didn't hit the top truss cords that came down at the truss ends. And this figure here shows, I have orange highlights where the posts ended up. With the 10-degree skew we had at the piers, we couldn't do everything just straight across. We had to have some unique floor beam spacing at the truss ends. But for the most part, our floor beams were just spaced at 4'2". Expansion joints. We had real low road speeds here on this bridge, and the approach roadways is just dirt road leading up to the bridge. So we had road speeds of just about 15, 20 miles per hour. And with those low road speeds, we determined that just taper plates would be a simple and economical solution. Just put some textured surface on that to provide traction, and just had it bolted one side of the plate to the deck panel. The other side of the plate was allowed to slide for temperature and shrinkage, all that, temperature stuff. So the bid process and results. Before we went into bid, we had a PS&E review with MDT, and this really aided us in developing an accurate engineer's estimate. Our costs did increase from our preliminary estimate due to inflation, adding in roadway costs. Though our engineer estimate of $3.23 million, fell right between the number 2 and 3 bids, so it's a pretty good estimate overall. And Wadsworth Brother took home the winning bid at $2.7 million. So let's get into construction. Construction timeline. We had the letting date of June 9th, 2022, and a contract time period of 80 working days. We had a contract notice proceed date of no later than April 17th of 2023. It's obviously before April, so the contractor decided to take advantage of the flex time that was offered in the contract and to start work earlier. They still just had 80 working days, but they were allowed to have an earlier start date if they so desired. We received our first submittal from them July 8th, and we signed off on the last submittal on September 8th, so just a 3-month process right there. With Wadsworth Brothers starting construction on September 13th, they finished and reopened the bridge by November 23rd, which was the day before Thanksgiving, and that was a total construction time of 72 calendar days. With Wadsworth Brothers Construction, they worked most weekends, so that's a pretty accurate reflection of their working days, so they ended up coming in under the contract time, which is great. An interesting thing to note is during the bid process, we had some contractors reach out to us asking for if they could have more than 80 days because they weren't sure they could get it done in that time frame, but Wadsworth Brothers came through and finished in the time allotted and with time to spare. So for the installation procedure, first they had to remove the old deck. Then the process they went through is they put down some floor beams, put deck panels on top of those floor beams, drove on top of the floor beams, put down more deck panels, more floor beams, put in expansion joint plates as they're going along. At first they were putting in railing first, later switched to doing the concrete first. I'll talk more about that later. And at the end, they fixed up the roadway approaches. So first, as mentioned before, they had to remove the old deck. Now the old deck the timber ties were held in place by just these small little metal clips just bolted on there. Many of them had fallen away or were missing. So it was pretty easy for them to just loosen those up and pull the old deck off. So that came off pretty quick and easy. On the right side, there's an image showing the structure with the old deck removed. Next, they had to drill holes to place the new floor beams. Just had to bolt those new floor beams to the top of the existing stringers. They ended up using one of the new floor beams as a template. They just pushed that down along the top of the stringers, just sliding along the way, marked where the holes needed to go, continued sliding it down, just all the way down the structure, and that worked out really well. And they did end up leaving the makeshift cable railing on there. They used that as kind of like a tie-off point for themselves as they're on the structure. So it ended up working out nicely that way too. So for deck panel installation, an interesting thing to note is they used this telehandler to move the panels into place. And during the design process, we looked at local rental places to see what type of equipment would be available locally. And we located this telehandler, may not have been this exact one, but a similar one at least, and determined how big we could make the panels that this telehandler would be able to lift and move into place. And the as-built plans, they did allow the contractor to adjust paneling sizing if they wanted to, but for the most part, they kept everything the same. So it's just nice that that design consideration came into play and worked out real nice. They just had one person in each corner as they put the panels into place to make sure everything went into where it's supposed to. And then as needed, they put in the expansion joint plates over the piers. Those went in pretty simple. They're just, like I mentioned before, they just bolted on one side and then continued going down. And with the railing, they started putting the railing up as they're going down, but after they did a little past one span, someone came along and said, hey, how are we going to get the concrete blankets on over these joints that we're going to put in? And they're like, yeah, these posts might be in the way. Let's do those later. So after they did one span, they decided to put the rest of the posts and railing in after they've poured the concrete. So speaking of the concrete, our deck to floor beam connection, we end up doing these concrete headers with shear studs on top of the floor beams to anchor and get everything interconnected. We first looked at possibly doing like a bolted type connection or welding, though after speaking with some of the local contractors, they were concerned about getting their tools down through the metal grid deck to tighten bolts or to weld. And so after taking this concern to BGFMA, they recommended using this concrete joint that had been used out east before and been successful out there. So we decided to do that. That would allow the contractor to install everything from on top of the deck. They wouldn't have to get under the deck at any point. They could just keep going down the way and make their life easier. And this also helped us at the deck to crossbeam connection, as I mentioned before the floor beams raised the deck up a little higher, which was useful for giving us more clearance, but this did cause an elevation difference at the existing cross beams. Though we're able to use the concrete to make up that elevation difference, they just had to put in some temporary deck supports to hold the deck at the proper elevation, and these temporary supports also act as formwork for the concrete, so just multi-purpose right there. For the concrete, it went in pretty smooth and simple. They just drove the concrete truck right on top of the deck paneling that was out there. Sorry, not deck panel, yeah, metal grid deck panels. So they're able to just drive it out there, just pour the concrete, just used a board to help guide it into the forms, and just smooth out. It went in pretty smooth and easy. There were a few unexpected things as we were going along. Turned out the galvanizing process warped a few of the deck panels. Most of them rested flat, but some of them bowed up a little bit near the ends. A simple solution we came up for that is just they used their telehandler to hold it down flat, and they just tack welded into the deck panels in non-tension zones. We had to run some analysis just to determine what areas were tension zones, what area were not, just to make sure that no tack welds ended up in tension areas. I've got a before and after image right here. This after image was taken shortly before concrete was put in, though it gives a pretty good idea of what the end structure ended up looking like. We did go back up after it snowed and took a few more pictures. And the snow ended up falling straight through the deck and not accumulating just as we had hoped. And there's a little bit of accumulation on top of the concrete headers, but nothing that would be a point of concern. So we haven't heard any complaints back, so we assume everyone's happy with the end product. On this last slide here, I have a contact information. Put up some fancy QR codes that you can just snap a picture of if you want contact information. And well, is there any questions from the audience?
Brent, in your options, your option that got accepted was a little more in cost, obviously, but did you
Right.
take any credit for user costs? Because I got to tell you, the county's saving some money in regards to maintenance on that bridge for not having to plow it and deal with those items. So, I don't know. I'm just curious.
Not really. So what was kind of funny is the MDT's PM, he was just like, let's just make the county happy. The county had been really pushing MDT to get this project done for years and years. So to actually get it moving forward and to come up with an option that would really help them out and make them happy was just kind of a win for MDT. So yeah, once they kind of zeroed in on that, MDT kind of just went right along with it. It wasn't terribly more expensive than the other options, and it seemed to kind of solve a lot of their issues.
Yeah. Did you guys do any analysis beforehand to ensure that there was no members that needed to be strengthened before the deck replacement occurred?
Well, like I said, we did a full load rating analysis, modeled the whole truss, and made sure that it wouldn't anything we put on there would compromise capacity. And what we found is that the truss is in relatively good shape. Capacity is not an issue, and what actually controlled the capacity of the overall rating was one of our new members that we put in. So it actually limited it. I think it was still 1.442, I think, but so well above 1. But the new floor beams are now controlling the overall rating.
So your legal loads included any construction type loads?
Oh yeah, we checked for construction loads. So when the panels would be in for them to drive on. Is that what you're asking?
Yeah.
Yeah. So, and then now that it's the new deck's in place, there's no restrictions.
Did your load rating also include gusset plate analysis?
No, we didn't go into that much detail. What's that? Oh yeah, actually it is a pin connection. Yeah, the thing on that was there was matter of fact, the as-built plans for this truss are a carbon copy of another truss that's not too far, I think, from this one, and we had rated that one in detail, and just there was a very in-depth inspection done on this bridge right before we got there. So we didn't have to, it was a fracture critical analysis. So the bridge was in very good shape, and we were able to take that model verify that it was truly the same configuration and make sure everything worked. So.
Quick question. You said that the public perception drove some design decisions. Obviously, the bridge was built in, what, it was 1907?
Yeah.
Was there any historic preservation considerations or things like that that affected the design and or the scope of the design?
No, they just wanted to get the deck replaced. That was their big thing. They wanted to keep it in service. We did talk about how the weathering steel would kind of match the look of it right now, but there was no real doing it this way just to keep it more historic or anything. So.
Okay, I think that's all the time we have. Thanks, guys. Appreciate it.
Thank you.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.